Hi, I'm Glenn Thacker. For this project, I had to step back to the snap circuits kit, unfortunately, and will return to breadboard projects as soon as I can. But in the meantime, I had to use the snap circuits kit, and I built a tone generator, which is pretty cool. It's a pretty simple circuit. As the power is switched on, and electrons begin to flow through the negative terminal, conventional current is able to follow a conventional path through the resistor, dropping it to about 0.25 amps to turn on the NPN resistor, and also to complete the circuit, running past the capacitor into the whistle chip and powering the speaker. And the push-pull dynamic that the transistors create in conjunction helps bounce the whistle chip. And bouncing that whistle chip, it's really acting as a capacitor. And then looking at the speaker, once again, we have another complete circuit. Well, once this circuit is complete, and the power down from the emitter to the collector. And that's what creates that push-pull dynamic on the speakers, the two transistors working in conjunction. And we can also take a look at the capacitance in this project, because the capacitance is pretty much a frequency modulator. Like if I added this 0.02 microfarad capacitor on top here in parallel with the whistle chip, it increases the frequency, and so it changes the tone. So the first tone being in E flat, in the 6th octave, E flat 6, was giving me a frequency of about 1,244.51 hertz. And that second tone was an F5, and that gave me a frequency of 698.456 hertz. So as you can see, as we increase the capacitance, we changed the frequency. The frequency went higher. But on this circuit, using a 10 microfarad capacitor before that whistle chip, actually decreases the capacitance of the whole circuit, because when you place capacitors in series, it increases the space between the plates. And although this circuit was not built with a 555 chip, it still creates an oscillating wave. This circuit is usually called an emitter coupled oscillator. And what happens is the NPN transistor amplifies the positive going voltage, swings, while the PNP transistor amplifies the negative voltage swings. The output of the amp signal is fed back to the base of the other transistor, and that creates a positive feedback loop. And that loop causes the transistors to alternate between and turn on and off, generating a continuous oscillating wave. And of course, the resistors and the capacitors help smooth out help control the frequency and smooth out the path, and generates our tone. If I have to continue making videos in this series using the snap circuits kit, that's okay. I should be doing some projects with some chips in them anyway. The thing I don't like about the snap circuits kit is it does have, 3 IC chips that I can use for music, but everything in them is already pre-programmed, and I've been soldering breadboards together with limited success, but still I prefer that much more than the snap circuits kit. The chips, like I said, they're already pre-programmed, so I can switch the connections on them to give different sounds that have already been stored inside. And although that does demonstrate the principles that I'm learning in the class, it to me it seems like a complete workaround. So I'll try to get back to the breadboard projects as soon as I can. I really love doing those. But this was my video today. Thank you.